Good morning. Today we are going to discuss another method of solving multi-story frame. These method are approximate method. So this method is called factor method. So we are going to start with factor method. The factor method. This method is more accurate than portal method and cantilever method. We have studied this portal and cantilever method. So the factor method is more accurate than all of these two. Especially useful when moment of inertia of various members are different. This is useful where especially when moment of inertia MOI is different for different section. So the basis of vector method are: at any joint the total moment is shared by all the members in proportional to their stiffness. We know stiffness is K, which is force upon deflection. So this total moment is shared by all the members in proportion to their stiffness. And second is half of moment gets carried over to the far end. As we know, when the far end is fixed, the half of moment is carried out by the far end. And in this multi-story frame which is subjected to horizontal force, we know every member is fixed and every member is rigid, so far always the moment will be shared by the far end is half of the moment. Now what we do in this factor method: girder and column factors. The girder and column factor, which is relative stiffness of a member, is equals to K is equals to I by L. As we know, if far end is fixed, the stiffness factor will be relative stiffness will be 4 EI by L, and if far end is hinged, the stiffness will be I by L. We have studied this in moment um, in the method called in the this method. Okay, girder factor at a joint G is equals to sigma K of all columns meeting at the joint upon sigma K of all members meeting at the joint. If we have given a notation, girder factor as G is equals to sigma K of all columns meeting at that joint upon sigma K of all members meeting at the joint. And now column factor at a joint is equals to C is equals to sigma K of all beams meeting at the joint upon sigma K of all members meeting at the joint. Also we can find out this column factor will be 1 minus G, because this C plus G will always equals to 1, because these are these are only factors. Now moving towards the next step, moment factor of a member. This capital C is moment factor, which will be Cm is column factor, Cm into K for a column, and this G is equals to Gm into K for a beam, where Cm will be C plus half of column factor of far end, and Gm will be G plus half of girder factor of far end. Because we know this moment will be shared by the far end is half of the moment, so factor will also be shared by the far end is also half. So Cm will be 1.5 into C, or Gm will be 1.5 into G, because C plus half of C and G plus half of G, where sigma is C is sum of column moment factors for a story, and sigma G is sum of beam moment factors for a joint. Sigma C is moment of column sum of moment factor of a story, and sigma g is sum of beam moment for a beam moment factor for a story for a joint. Now we'll take a problem. By the use of this problem we understand how this method will work out. So by solving this problem we will understand this factor method. Analyze the frame using factor method. In the problem here is shown two horizontal force 40 and 80 kilonewton. On top story this 40 kilonewton load is acting, and on bottom story this 80 kilonewton load is acting, and these are the columns A, D, G, B, E, H, C, F, I, and the vertical distance between two stories is 3.5, and then this length of beam this GH is 5 meter, also DE is 5 meter, HI is 7.5 meter, EF is 7.5 meter, and these columns length is 5 meter, 5 meter and 5 meter. So we will start this method. So total column moment about DEF will be this, we can see that on this DEF will be 40, this 40 kilonewton into 3.5 meter length, so 40 into 3.5, which will be 140 kilonewton into meter. And now total column moment about ABC will be this 40 into 3.5 plus this 80 into 5, this will be 740 kilonewton into meter. Okay, we find out this total moment. Now moving towards the next step, this is the table we will going to make, and all the factor method will cover in this table. So first we take joint are D, E, F, G, H, I, A, B, C, and now then member in column, all column are taken. So at joint D there are two column DA and DG. At joint E there are two column EH and EB. At joint F there are two column FI, FC. At joint G, GD. At joint H, HE. Joint I, IF. And at joint ABC, AD, BE, CF. These are columns. Now at joint D there is only one beam, DE. At joint E there are two beam, ED and EF. At joint F only one beam, EF. At joint G only one beam, GH. At joint H, HG and HI. At joint I there is one beam, IH. And on joint ABC there is no beam. Now the first step is find out the stiffness. So stiffness we know I by L for column will be 4 EI by L we know. So EI is constant, so we are taking only factor. So 4 EI by L 4 EI by L. L is, we know L, here L is so no, K is equals to I by L, we know I by L. So here I is constant and L is 5 meter for DA. For DA column L is 5 meter, so I by L will be 1 by 5, so this is 0.2. And the length of column DG is, the length of column DG is 3.5 meter, so 1 upon 3.5 meter will be 0.286. So the remaining stiffness is also similar to find out is at joint D, and the stiffness of beam is also I by L. We will do I by L, so we will find out the stiffness. The remaining portion will be covered in the next video.